Good sound. Anyway, so I'm going to talk about the HTAP Fires multi-model, multi-pollutant project. Um, so what we have at this time, it's been kind of in the works for a year and a half or so, maybe 2 years. It's a plan, it's a modeling plan. So we have like a model experiment description paper now posted online, the preprint. So it's finally in review. But the objective of the study is to improve our understanding of the intercontinental flows, like long-range transport of air pollutants related to open burning, and looking at multiple impacts such as health, ecosystems, and climate, as well as air quality from the regional to global scale. So we're doing this via modeling. There are several models and model types that will participate, and we're going to be covering several pollutants, all of which are under this HTAP convention. So ozone and ozone precursors, methane, particulate matter, cloud forcers, even mercury and POPs and pHs and stuff like that. So biomass burning, as we know, it's a major source of all of these pollutants that the convention covers. So that's why there's a desire to have a focused study on biomass burning. So it's the HTAP Fires. It's one of 3 HTAP modeling projects that are currently underway or starting to happen. And sorry, I didn't sort of say at the beginning, HTAP is the hemispheric transport of air pollution. I think you've never heard of it. So the other projects are one more focused on ozone, the OPENS, so it's a multi-compartmental, oh no, sorry, I'm reading the wrong one. Ozone, PM, nitrogen, and sulfur deposition. And then the other one is the mercury-focused one, multi-compartmental mercury modeling analysis. But basically, because these 3 projects are happening kind of under the HTAP umbrella all at the same time, each set of experiments is trying to harmonize as much as possible using similar emission data sets and stuff like that. So yeah, I mentioned this scope. The impacts are ranging from human health, climate and radiative forcing, ecosystems, socioeconomics and fire management, and transboundary issues. And then I mentioned already all of the pollutants, most of the ones you can think of. And then a wide range of modelers are encouraged to participate. So the climate Earth system models, the chemical transport models, multimedia POPs models, et cetera, et cetera, et cetera. It's a big undertaking, let's just say. And then the idea is to okay. So then this community, through several online meetings, we've come up with a list of science policy questions that we're going to try to answer with this modeling project. And it's not a full list of them, but it's the gist of them are covered by these. So like, what are the impacts of fires? How will those impacts change over time, including into the future? How do the plume dynamics and plume chemistry impact the downwind? What is the range of variability and uncertainty? So like, if you have many models simulating the same thing, how big of a spread do they all provide? How well do the models perform against observations? And what are the similarities and differences among all of the pollutants that we're trying to cover? So from fires. So we've, through a lot of exploration, we discussed several options, and we've come up with some guidelines that we'd like modelers to do. So for example, the simulation time periods, we've got, because there's a range of models that all, have different kind of computational expense, we've got like a short, medium, and long range time period option for the historical period and for the future period. So I know GEMMAC, which you saw at Rodrigo's presentation before, it's very expensive to run, so it can only do short time periods. So in that case, we're saying the short option would be to do some case studies So some of the big fires that we've heard about, you know, in Australia 2019-20, and in California and in Canada, basically we do some short case studies, and then, but then the medium option is more like a 5-year and then a long 20-year almost option for the longer, like more climate focused models. And in the future, we hope to simulate out to 2050, because that's the scenarios that we have provided, and they go out to 2050 into the future. We're gonna leave the 2100 long range predictions to the CMIP 7. We're not gonna try for that. And then we have decided on the emissions we would like the modelers to use as for the baseline simulations. So for the fire, so in November 2023, we held a workshop co-hosted between the Be Burned activity and HTAP to go over all the different emissions data sets, and we saw, like in Patrick's talk, some of that kind of intercomparison was presented there. And then after all of that workshop, we decided on going with GFAS for the baseline biomass burning emissions. Johannes provided like a kind of an updated version, which he's calling the NILU GFAS version 1.2.1, because there's been a few updates. But yes, so that was chosen because it provided some plume height information, it provided like a diurnal information, and it included both tropical and boreal peatlands fires emissions. Even though we know they're highly uncertain, this was why that data set was chosen. And then for the future fire emissions, there are not a lot of options. FireMIP is, which we heard about, is going to create some, but they're not available yet. And so the only ones we knew of that were available are from this Hamilton and Kayser et al. Project, where they use CMIP 6 models that had the interactive fire modeling, like similar to what Karen presented earlier. And they have future fire emissions that respond to climate, because otherwise most future data sets only the future scenarios for fire are just based on land use change, and they're not taking into account a warming and possibly drying climate. So this data set does, so that's why it was chosen. And then so on and so forth. Each HTAP has historical fire emission, anthropogenic emissions, and then this IASA gains has future anthropogenic emissions. And for biogenic, we're basically saying most modeling centers could just use their default, but this negative one is quite common among models. So, okay. And so this is like a huge project with many experiments. So the guidelines I just showed you are for the baseline simulations, but then there's the case studies, which I mentioned, fire emission sensitivity. So if modelers, so I will just say that all modelers can opt into as many or as few experiments. We would say the baseline is a priority, but after that, anything they have resources to do is welcome. So fire emission sensitivity. So if the modelers want to use different biomass burning emission data sets, they could, and we would intercompare those results. Then we have prescribed future fires versus in number 4 versus interactive future fires in 7 to compare, like if you're prescribing the fires versus if you have interactive fires that are responding to climate in that model. And then there's the regional and sectoral emissions perturbations. So that little map I showed in one of the former slides, basically we turn on and off emissions in each of the colored areas to get at what those areas contributed to air pollution downwind, and so on. And data simulation. So Ilan pointed out that there are some data simulation models that might want to do some experiments for this too. And then with those, they can get at how the emissions data sets should be scaled and so on. So all of those emission data sets should be available as of very soon this fall. So in the next month, I would say all the data sets should be available, and that means modelers can take them and start formatting them to work in their models, and then start model simulations throughout 2025. It does take time to technically set up. I think Patrick kind of alluded to that, like, yeah, there's emissions, but getting them to work in your model takes a lot of technical work. So anyway, we expect that people will get all the input they need by the end of this year and be able to start running throughout 2025. And then the analysis can start as soon as the model output becomes available. There'll be a central model data storage place, this Aerocom website. If people are interested, they're encouraged to create an account at that early on, so that when their model output's ready, they're good to go. And then the hope is that the analysis and most papers that will come from all of this model data will come out around end of 2027 or so, which is good timing for the HTAP kind of cycle, I guess, but also some other coinciding cycles like AMAP, Arctic Modeling Assessment. They also have a timeline where they inform the Arctic Council of new findings by every 2 years, and this would fall there. There's other reasons why, but hopefully by then there'll be most of the research will come out of all this. And it kind of leads to the discussion we'll have after lunch, which is related to the special issue. If we want to include HTAP Fires papers, it will impact the timeline we select for the burned special issue. So I think that's all I wanted to say. Oh, just, sorry. Just if you are not on the HTAP Fires list and you'd like to stay in the loop, this is how you would join. And then I also threw in the burned email list too. Yes, okay, now that's all I'll say. Thanks.
Thank you, Cindy. Questions?
Is there an opportunity for those of us who have interesting data sets to volunteer to be a case study? Because that would be a really nice outcome for us.
Yes.
Have that modeling capability at all.
Yes, that would be great. In fact, so in this big model experiment design paper that's published, we do have a table of observations, and I really tried to get people to provide information for that, but it was hard. I guess, like, I don't know the right people who are willing to, but yeah, basically I would be very interested because we are trying to come up with a hunk of data, observational data that we can evaluate all the models with.
And then other models, I mean, can be like the models that we do have can be compared with the HTAP ones.
Yeah.
Sounds cool.
Yeah.
I will email you.
Thanks.
Other questions?
Cindy, is Terry Keating still leading the HTAP activities?
Yes, yeah, Terry Keating. And Tim Butler's really taking leadership on the ozone one, and Terry Keating kind of all of them, but he seems more Mercury one.